All right, so we're finally at the point. Finally at a new chapter, chapter 8. So this is a chapter on building Java programs, specifically classes. Okay, so this is going to be a bit of a different chapter because, believe it or not, we've not been using Java as intended right now. I mean, it's a perfectly valid way to do Java right now, which was using Java as a procedural language, but here we're going to be looking at how to use it as an object-oriented language. So we're going to learn how to build classes, right? So we've learned in great detail how we can write methods, which is how we write our own new commands into Java. And now we're going to learn how to build our own new data types. So let's first start out with a use case. So here's a problem that we can solve using our drawing panel that concerns the drawing panel that we've gone over a couple times. So we've got a file, and it contains the XY coordinates of cities, and it begins with a number of cities. So 6 cities. The first one is at location 5020. The second one's at location 9060, and so on and so forth. Okay, so the problem is, let's write a program that draws cities on a drawing panel. So it draws these cities over here, kind of like a dot, and then the coordinates of them. And then it drops a bomb that turns all the cities reds within a given radius. Kind of a morbid problem, but hey. So the blast site so we put in the point where we want the blast site, so 100 and 100, and then how big the radius. So anything that's inside the radius will get turned red, and anything outside the radius stays black. Okay, so just a pretty simple problem, or rather simple to understand. Okay, so the question becomes, how do we construct this thing? And it's actually perfectly able to be solved with what you know right now. You can solve this problem with everything you currently know, right? Especially about, with regards to the drawing panel. I mean, you might not know, we've never really done graphics, but through graphics make a great example of how to do this. So we're going to refine our solution. We start with a bad solution, but that's what we know how to do. First thing we'd do is we'd get a scanner. We'd take in cities.txt into a scanner, and then we'd start scanning it. We'd first read the first line, right? To get the number of cities, because the first line contains the number of cities. So that tells us how big of an array we'd like for the cities. But one array isn't going to cut it in this case. Notice here that in bold, we have 2 arrays, one for the x coordinates and one for the y coordinates. And they're the same size. Why do we have 2 arrays? Well, because we have 2 groups of integers. We have x integers, and then we have y integers, because we have x coordinates and y coordinates, right? We could create one array. The alternative is that we could create one array called towards that's twice as big as the city count, right? And index 0 would contain the first city's x coordinate. Index 1 would contain the first city's y coordinate. Index 2 contains the second city's x coordinate. Index 3 contains the city 2's y coordinate. So index 3. As you can see, it's already getting confusing, right? And we would write a method to translate that, but still, it seems a bit unnecessarily confusing. Similarly, though, having 2 parallel arrays that are related to same data, is considered a bit bad design. So, but the way this works is that we just go ahead and we read in the points of all these cities, right? We read in the x coordinate, then the y coordinate, then the x coordinate, then the y coordinate until we're done. Okay. It'd be better though if we could just, have a bunch of little point types, data types to store the x and y coordinates, right? Because then we could view it as actual points, because that's what these are, right? These are points on a field. These are points in a grid. It'd be better if we could reframe our thinking, so we don't have to remember, okay, this is the x coordinates, this is the y coordinates, or this is the giant array, and then the evens are x's and the odds are y's, and right. It'd be better if we could just create a point object, a point that would store, some x up y data, and then we could use that to compare distance between points. We could keep the points would know how to draw themselves on here. It makes the program nice and smaller and neater. And the idea is that we can do that. We can finally learn how to make our own data types. Okay. And what we're going to do is that we're going to start working with multiple files that, work with one another. We'll have a client program, a program that uses the objects. This is typically going to be the program with the main. So typically we only have one class with the main method in there, and then it's going to use a bunch of other classes. So, and we're already doing that now with the bomb.java program. It's going to be using the drawing panel.java class. Now, over here, with what I've got set up, I've got it importing the the drawing panel, and it creates the drawing panel. So this guy is the client program, and we build it, and it uses drawing panel. Oh, I'm running the wrong one. So Shift F10. Why aren't we running run? Right. So this program runs, and we've just got our blank field here, right? So we want to build from this canvas. Okay, so going all the way back when we were talking about classes in Java, there are two types of when we write a class, it's a program. When we write a program in Java, we can either write it as a program, right, or a module. Basically, that's what we've been doing for right now. It's a program that contains a main method and calls a bunch of other methods to do what it needs to do. That's what we've been doing for right now. The other thing we can do when we write a class is we can write a template for building new types of objects. So over here, right, in our packages, let's see, drawing, it's in graphics, we have our drawing panel, and the drawing panel is some code that somebody actually wrote, and it tells you how to create new drawing panels. It tells you how to make these. These are instructions for the computer to make new drawing panels. They're also instructions for you to some extent. Okay, so what we're getting into is something called object-oriented programming, because what we use is we write these classes and we use them to build objects. So these are two new terms that we're using that we're going to define: classes and objects. So actually, class and object, we've been using them, but now we're actually going to define them. So what is an object? It's essentially a new data type. I'll give my definition, then I'll read theirs. But an object is a new data type. It is a new type of data, and it just like creating like a scanner or a string, and it has two things. It has both actions that it can do, and it has features. So it has basically data inside of it, and then it can do things. And the way we're going to start organizing our code is in terms of object-oriented programming, meaning that programs will basically be written as one object talking to another object or interacting with another object. Because that way, because when we group things like that, it becomes easier to think about it and easier to organize it. So the analogy is so what's the difference between a class and an object? So classes are a template for building objects. They're the analogy that almost everybody uses is a blueprint. A class is a blueprint for building things, and those things that you build are the objects. So for instance, here's an iPod blueprint. Each of these are first generation iPods, they have a state. These are like basically features that basically are independent for each iPod, right? So you have a bunch of different iPods. They're all going to be on different songs. Volume, they're all going to have different volume levels. Each of them are just going to have their own battery level, right? And that intuitively makes sense, right? This guy has 2.5 hours battery life left. This one has 3.41 hours of battery life yet, right? It makes sense that not all the iPods in the world are going to have the same amount of battery life. They're not all going to be on the same song, and they're not going to have all the same volume, but they're all features that they do have, right? All of them do have a current song, they have a current volume, and they have a current battery life, even though those values can be different. And we can do the same thing to all of these things. We can power them on and off. We can change their songs. We can change the volumes. We can, shuffle them around. So when we write objects, we define things. We define the state, and the behavior. We also define one last thing, which is also how to build them, but getting a bit ahead of myself there, but you can basically classify it into state and behavior. And the reason we do this is that we want to be able to use things without necessarily thinking too deep into the behavior. We don't have to understand how to use a iPod. In order to use an iPod, we don't have to understand what goes on underneath it. We don't need to understand the circuitry. We don't need to understand the board. We don't need to understand the code behind it. But to use it, we just have to understand, okay, if I push this button, I'm going to go to the next song. If I push this button, I'm going to go to the menu. If I do this, it's going to increase the volume, right? If I call this method, it's going to increase the volume. If I call this method, it's going to go to a new song. You don't necessarily have to know how the program works if you have been handed an object. You just need to read the methods and see what they do. So this is a big feature, this abstraction. It makes it easier to think about stuff, right? Just when you're writing Java programs, you don't need to think about how an individual program works at the low level. Okay. So let's see our task. So what we're going to do is we're going to write this program, and we're going to do it using a point class, which is pretty easy. And then I'm going to move on to shapes. Your task this week is with an object is to learn how to write your own basic shape. We aren't going to have to draw anything, but you're more than welcome to. But we're going to learn basically how we can make an object to kind of model a shape. Last thing I want to mention before this video, before I move on to the next video, because I'm trying to break this up into manageable chunks, is that Java is what we call an object-oriented language. So once we learn about what objects are, we're going to learn about the 3 features that make an object-oriented language object-oriented. Okay, and I'm going to write them down for you so that you can copy them down because they're sure to show up on an exam in some way, shape, or form. The first one is encapsulation, which basically means that we want to keep things separated. We don't want to this goes back to the abstraction slide that we just showed you. We want to keep we don't want you to get too bogged down into the details when somebody hands you an object. You just want to understand how to use it, and what happens when you use something, not necessarily how the innermost workings of it work, right? When you drive a car, you don't need to know about how precisely the engine works. You don't need to know the exact sequence of events. If you turn a key, what happens to the engine? You just need to know if you turn the key that the car turns on, and this concept is encapsulation. Okay. The next thing that we want to use for an object-oriented programming language, inheritance, which is the idea that we can smartly reuse code. We can basically say this thing. Well, there are other things that are basically subtypes of it, right? You have students. Well, we have multiple types of students, graduate students and undergraduate students, right? So we can have a common student object. We can write code for a student, and then we can further define it and reuse it in for both the undergraduate student and the graduate student. And the last concept, which is tied to inheritance, is a big scary word called polymorphism. Okay, and that just means we can treat objects as objects as other types of objects whenever we need to. All right, so see you in the next video.